Okay, Wilson, I heard you talking about this particular problem. Which method did you use to solve, or what did you do to solve it? Vertical line? Okay, so Wilson made a vertical line. Why did you do that?
So like it separates two shapes.
So I get two rectangles. So what is the area of one rectangle? 10. I'm going to take 5 times 2. So the area of that rectangle is 10. Then I have another rectangle. What are the dimensions of that rectangle? 2 and 4. So I'm going to take 2 times 4, which is 8. So the area of my figure would be 10 plus 8, which is equal to 18 square centimeters. Did anybody else work through it differently? Who just came in the room? Who? Oh, what did he do? Gotcha. He handed you something. I was like, why would Jonathan Andrews be in here? No, he does not. It might be with Mr. Levine. Okay, what did anybody else work through it differently? Okay, you did it horizontally. Let me see if I can do this. Yes, I can. All right. So let's look at it, Jada's method here. Because there's more than one way we could find the area of this particular figure. All right, what did you do, Jada? That was 2, right? Okay, so you made one long rectangle on the bottom. So when you did that, we had 2 figures again. This bottom rectangle, what were its dimensions, Jada? The area is 12. So we took 6, which is the length times the width of 2, and we got 12. Then you had another figure, which is this top rectangle. And in the top rectangle, you had dimensions of what? 3 by 2. So 3 times 2 is 6. So you took 6 plus 12, which is 18. So we ended up with 18 square centimeters again. Anybody else work through it differently than one of those 2 methods? There is a possibility. There's another way. Does anybody know what that method might be? Something that Eric Ackerman would do. What happens if I look at this figure and I say, I have this large rectangle right here? What's the dimensions of that large rectangle? 6 by 5. So I have a 6 by 5 rectangle, which gives you an area of 30. But what I want to do is I want to get rid of this color. I want to get rid of this rectangle and chop it off, right? So the dimensions of that rectangle are 4 by 3. So I'm going to take 4 times 3, which gives you an area of 12, and I want to get rid of it. So what happens when you subtract those? You get 18 square centimeters again. So there's 3 different methods of ways that you could view that figure and break it down into smaller parts that you know, or look at it as a large rectangle and subtract a little piece from it. I don't care which method you choose. How many chose the blue method by drawing the line vertically? I know Wilson did. Okay. How many drew it horizontally like Jada? Anybody? I'm guessing nobody subtracted, otherwise you just didn't mention it. And I asked you that. Okay, I have another problem for you. With your partner, I will give you 90 seconds. It is 10. I will slide it up. I will give you, maybe I'll just give you a minute to go ahead and find the area of that particular figure. Go. Ethan, what did you do? Okay, so you found the area of the large rectangle, which was 8 times 10, which gave you a figure, or the area of 80. That would be if I talked about the whole large rectangle. But then what you had to do is to find the area of the shaded region is we needed to subtract this smaller rectangle from it, which had dimensions of 6 by 2, which was 12. And if you subtract that correctly, you get 68. I'm not quite done yet. What do I have to do? Square meters per units. Remember, don't put your square right after the 68. So we have 68 square meters for an area. Now I have a triangle. When I talk about the area of triangles, the area of a triangle is, if I were to take a rectangle, what happens if I split it in half? What do you get? You get two triangles, where the area of just one of them is how much of the area of a rectangle? Half. So the formula for area of a triangle would be base times height divided by 2. Length times width divided by 2. Is there a difference between base times height divided by 2 or saying 1/2 the base times the height? Is there a difference between those two? No. Those are exactly the same. So if you don't know what the area of a triangle is, I would write that down. Area of a triangle is base times height divided by 2, or half the base times the height. They both mean the same thing. Do you have that or not? Let me change the slide. We have different types of triangles. What are some different types of triangles we have? What's isosceles? What's another one? Scalene. Right. Oh, here's a right triangle. What's the base? 4. The height is 3, and I divide by 2. Mentally, what are you doing in your calculation? Are a lot of you saying it's 12 divided by 2, which is 6? Is anybody saying, okay, so I could take that and say that is 12 divided by 2, base times the height, so I get an answer of 6 square units. Is anybody looking at that and dividing first? Can you divide first? Can I go 2 goes into 4 2 times, and 2 times 3 is 6? Yeah, that's okay. And sometimes, oops, square my units. Sometimes that's an easier calculation because you're not trying to take half of a large number. If you can divide by a smaller number first. So that's an example of a right triangle. But what happens if I have an isosceles triangle, for an example, like Wilson talked about, or this is an acute triangle as well? Where is your height in an acute triangle? Right down the middle. If it's isosceles, it's right down the middle. It splits it into 2 equal triangles. But what we're working with here is the height is going to be the perpendicular distance from what is called an apex, or the highest point, to the base. So you look for that perpendicular distance. So what's the area for this particular triangle? 4 times 3 divided by 2, which is still 6 square units. Just keep in mind where your height actually is. What's another type of triangle we have? Right, acute, obtuse. If you look at an obtuse triangle, where is the height going to end up? Not necessarily the smallest angle. Where does it end up? The height is found outside. It's right here. It's outside of your triangle. Don't use a slant height, which would be right here. We don't want the slant height. We want to use the actual height of your triangle, that perpendicular distance. So for this triangle, if I want to find the area of the triangle, the base is 4, the height is 3, and if you divide by 2, you're still going to get that area, just like on the past ones, of 6 square units. Just keep in mind where your height can appear, whether it's a right triangle, it's one of the sides. If it's acute, it ends up inside the triangle, and if it's obtuse, it ends up outside of the triangle. So there's the differences with triangles. I need you to find the area of this right triangle. Dimensions are in feet. You get 1 minute with your partner. Go. Okay, volunteer. What did you get for an answer? Macy. 24 square feet. And how did you find 24 square feet, Macy? Correct. The base is 6, the height is 8, or vice versa, and you divide by 2. Did you divide first? No. So you ended up with 48 divided by 2. If not, if I took 6 times 8 and divide by 2, 2 goes into 6. 3 times, what's 8 times 3? 24. How do you find the base or the height of this? Some of you think that 10 might be the base, but if you rotate this, all you were working with was a right triangle. A right triangle where the base is 6, the height is 8. You could rotate it the other way. You could find out that the base is 8, the height is 6, but you are still working with a right triangle. It's just positioned differently. Look for that perpendicular distance to help you find base and height.